Howdy, my name is Noah Mairino and I will be showcasing my demonstration Arc Music. I will first be talking about my motivations with building this project, followed with an explanation and description of the circuit. I'll then be transitioning into a demonstration of the circuit in action, following with concluding thoughts and future plans with the project. The motivation for this demonstration comes from the work of a YouTuber known as Frenzoli Electronics, a channel dedicated to Frenzoli's passion for music and electricity. Frenzoli is able to create music using groups of Tesla coils, or similarly to our demonstration, flyback transformers. Seeing his work on YouTube, I was inspired to recreate the easy flyback design showcased on his website. Combining his design with the work of our mentor's friend Salia Ruchiranga, we were able to design a similar circuit of our own, and after some changes, we were able to successfully produce a working unit which will be shown in this video. Here's the unit mentioned. As you can see, we have sectioned the circuit into 5 parts. These represent the 4 steps in the process of creating the plasma arcs. The first step is supplying the power. This occurs in section 1, the power supply. This demonstration uses a 24-volt power supply that provides a current of 5 amperes. This current will be increased to 15 amperes in the future. As you can see, this section has a blue resistor and a 12-volt Zener diode. As a result, this section limits the current and regulates voltage to 12 volts, which goes into the control circuit. The rest of the circuit is powered by 24 volts and the required current. We then move on to the oscillator. We precisely tuned the oscillator to generate a 22 kHz resonance frequency. This frequency allows for the firing of plasma arcs. The third section is the zero cross detector. The zero cross detector is able to detect zero cross points which occur when a wave intersects the x-axis. Take this simple diagram. We assume that the audio signal is a sine wave. The black points, as seen, are zero cross points, which are detected by the zero cross detector. Those points are where the sine wave changes its phase. The question is, however, what does this do? The zero cross detector allows for the circuit to turn the oscillator on and off. The detector takes an audio signal and detects zero cross points. Here are the schematics once more. Pin 7 of LM311 sends a signal to the oscillator timer circuit. In the oscillator time unit, pin 4 is connected to the zero cross detector, which is acting as a switch. When the detector detects a zero cross point, it sends a signal putting the 4th pin to ground, activating the circuit, and the oscillator generates the 22 kHz resonance frequency output for the transformer to create arcs. With this in mind, we can now move on to the 4th and final section, the MOSFET and flyback transformer. As you can see, there are a lot of capacitors. Notice the 3 red box capacitors. According to Faraday's law, due to the induced electromagnetic flux, current is generated in the opposite direction. In order to save the frequency-sensitive components in the circuit, the red box capacitors act as a high-frequency filter. In addition, in order to get a smooth, stabilized output, we are using 4 470 microfarad capacitors. In addition to these capacitors, there is a transistor, a diode, and 2 resistors, which are used to drive the MOSFET and flyback transformer. In summary, the oscillator drives the MOSFET gate driver circuit located in the power stage. This includes the resistor, the BC227 transistor, and the diode. From this, the MOSFET gate driver circuit drives the flyback transformer, firing the plasma arc. This transformer has 6 primary turns, with secondary turns that amplify and output the 24-volt source at a few thousand volts, resulting in a plasma arc through ionizing air. Due to the excessive heat produced by the MOSFET and transformer, a heatsink has been attached to the circuit to prevent overheating and heat damage. Let us now transition into the showcasing of the flyback transformer in action. With all this in mind, I would like to discuss my mentor AJ and I's future plans with this demonstration. We will first be testing the current unit to maximize amperage and performance. Our second objective is the creation and testing of a second unit. Once completed, we will focus on making the demonstration more physically appealing. This includes physical appearance and safety structures. This will be completed during the 2023-2024 school year and is projected to be completed by or before the 2024 Physics and Engineering Festival.